So here we have our Do Now. Santa's Helpers Inc., a holiday decorating company, is having a sale this weekend. They will do all of your interior and exterior holiday decorating for the prices shown in the flyer below. Write and graph a step function that models the scenario below. So let's look at the flyer. So up to 2 hours of work, they would charge you a total of $50. From between 2 hours of work up to 5-hour work, they would charge you a total of $100, and anything from 5 hours of work up to 8 hours of work would be $200. So pause the video, give it a try, graphing, choosing an appropriate scale, and then try and writing the step function. Okay. So for a scale for our graph, time is always going to go on our x-axis. So since we're going from all the way up to 8 hours, I would probably just go by ones. Right, and I'm going to label that hours. Okay. For our pricing, it goes from $50 being our smallest, $200 our highest. So let's see, could we do 10s, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100? Nope. We could do 20s maybe, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, and our 50 would be in the middle. I think that's probably what I'll do. So let's see, 20, 40, 60, 80. You didn't have to go by 20s, so if you used a different scale than I did, that's fine, so long as you were able to appropriately graph and you get a decent picture. And I'm going to label that cost in dollars. And I found it easier to graph first than make the function, but you may have thought otherwise. So $50 for up to 2 hours of work. So $50, that's going to be here in between 60 and 40. I'm going to do an open circle here because when time is 0, you wouldn't be paying them anything. Up to 2 hours of work. So I'm going to try and line that up as best as I can. Make a line there to the closed circle. Once you go past 2 hours of work, they're going to charge you $100. So we're going to do an open circle at 100. And that's up to 5 hours of work. So we'll do a closed circle at 100. Connect that with our line. After 5 hours of work, up to 8 hours, they charge you $200. So we're going to do an open circle at 200 and a closed circle at 200 and connect. Okay. Now, since these are all horizontal lines, their equations would all be y equals and whatever the y-intercept is. Right? We're using our piecewise function notation, so our y equals is given to us by f of x equals. So we're just going to put in what that y-intercept was, 50, 100, and 200. Then we're looking for the domain restriction. So you could write the word if, or we could just write that conjunction. Remember, the domain restriction is our x value, so we're just focusing on the x. So when y equals 50, we have our horizontal line at 50. It's from 0 to 2 in our x's. So I would model that 0 is less than x, and x is less than or equal to 2. Less than or equal to 2 because it has the closed circle. For 100, open circle at 2. Right, we're using that conjunction notation. Closed circle at 5. Y equals 200, open circle at 5. Closed circle at 8. So 5 is less than x, and x is less than or equal to 8. Okay. We don't need to put a title on our graph. If you want to, you by all means can. Santa's Helpers charge or whatever. And then notice I just erased those y equals. That was just for our thinking. It shouldn't be a part of our graph. Okay. So if we go to the next page, we're going to continue a little bit of a review of our piecewise functions. So we just did a step function, which is a specific type of piecewise functions where we have our pieces. Here we're asked to graph the piecewise function f of x equals x minus 2 when x is greater than or equal to 3, f of x equals 3x plus 5 when x is less than negative 3. Okay, so piecewise function, we have pieces of graphs. There were two ways we learned how to do this. One method was finding our starting point and then using our slope to graph. So if I'm looking at x minus 2, the starting point would be 3 when the x is 3. Then I'm going to look for what the f of x is, or the y is. So in my head, I'm just going to be substituting in 3 for x. 3 minus 2 is 1. Now I know the starting point is the ordered pair 3, 1. It's an equal to, so I know it's going to be a closed circle. So 3, 1. There's my starting point. With this function, I know the slope is 1. Which tells me go up 1 to the right 1, or go down 1 to the left 1. The domain is for all the x values greater than 3. So those are all the spaces to the right. So I'm going to go up 1 to the right 1, because that's including all of the points that have x values that are greater than or equal to 3. If I went to the down and to the left, that would be including the x values that are smaller than 3, which is not a part of our domain. So we're including all the x values that are greater than or equal to 3. We'll connect with a line and put an arrow. Okay. So we'll do that again with our second piece, which was 3x plus 5. And I'm going to use this little chart to figure out our starting point, which is negative 3. We've got our negative 3 for the x. And we want to figure out what our f of x, or our y value, is. So I'm thinking about doing 3 times negative 3 plus 5. 3 times negative 3 is negative 9, plus 5 is negative 4. Now, because this doesn't have an or equal to, I know it's going to be an open circle. So I'm going to go to negative 3, negative 4, and put an open circle. Here, our slope is 3. So that's going to tell me go up 3 to the right 1. Or if it were negative 3, negative 1, that would tell me go down 3 to the left 1. Well, up 3 to the right 1 would be here. And that would be having an x value of negative 2, which is greater than negative 3. Our domain restriction says x is less than negative 3. So I've got to go the opposite way with our slope. Down 3 to the left 1. Now that point has an x value of negative 4, which is in the domain. X is less than negative 3. So continue our points, make our line, put our arrows. If you found this method difficult, figuring out which way to use your slope, you could, if you wanted to, and it's a little more time consuming, but if that's what you need to get it correct, that's fine. We could use the entire table. So I've used negative 3 as the starting point. X is less than negative 3, so the next point would be negative 4. 3 times negative 4 is negative 12, plus 5 is negative 7. So the next ordered pair, negative 4, negative 7. And then do for when x is negative 5. 3 times negative 5 is negative 15, plus 5 is negative 10. The next ordered pair would be negative 5, negative 10. And then you've got enough points to make your line. We could have done it with the first one also. X is greater than or equal to 3. So the next x value greater than 3 would be 4. Substitute in. 4 minus 2 is 2. So the next ordered pair would be 4, 2. And you just keep going. 5 minus 2 is 3. Next ordered pair is 5, 3. and then 6. 6 minus 2 is 4. And just get all your points until you find the pattern or you feel confident. And then connect and extend the line. Those are both valid options. Okay. Now we're going to look at if we're given a piecewise graph, how are we going to write it using our piecewise function notation? So with that piecewise function notation, we're going to have our big curly bracket there, and then we're going to have the two pieces in slope-intercept form with whatever their domain restriction is. So for slope-intercept form, right, I need to know what the m and I need to know what the b is for each of these functions, each of these pieces of functions. I'm going to start on the one that's going this way first. That kind of starts there. So finding the slope and the y-intercept. I can see the slope. I'm going up 1 to the left 1. And I know slope is my change in y over my change in x. So up 1 is positive, to the left 1 is negative. So my slope is -1. Okay. I can see the y-intercept. It's right there. The ordered pair 0, 1. So I know b is equal to 1. So we know the equation is y equals -x plus 1. When we write that in our function notation, we're going to write f of x equals -x plus 1. Now I need to see the domain restriction. At the ordered pair we were given, that starting point is the ordered pair 2, -1. So the x is starting at 2. Every point on the line after that, right, up and to the left, has an x-coordinate that is smaller than 2. So it's going to be x is less than 2. Because it's a closed circle, it's going to be less than or equal to. So we've got -x plus 1. X is less than or equal to 2. And you could write the word if in there if you want. We see that sometimes. So let's find our next one. So I'm going to look at this function here, this piece of a function. Our slope is a little harder to see here. So we're given a perfect point here that's shaded in. I see this as the next perfect point. So it's telling us go up 2 to the right 3. Which is going to tell me that the slope is positive 2/3. Here, we can't see where it goes through the y-intercept. And if I try and reverse that slope, I'm not getting an integer point that goes through the y-axis. So we have to do something else. And there's two options. Okay? The first option I really like is to put the equation into point slope form because we've already calculated the slope and they give us a perfect point, our starting point, 2, 2. So why not use that? Just make this y minus 2 equals 2/3 times x minus 2. Now we just have to put into slope-intercept form. So we could distribute y minus 2 equals 2/3 x minus 4/3. I have to add 2 to both sides. As I'm adding 2, right, I'm thinking about common denominator. 2 with a denominator of 3 would be 6/3. So -4/3 plus 6/3 would be a positive 2/3, giving us our equation in slope-intercept form of y equals 2/3 x plus 2/3. Okay, so I'm going to show that as y equals, or f of x equals 2/3 x plus 2/3. And our perfect point there was the ordered pair 2, 2. Okay, and we can confirm it was a closed circle, which is honestly really weird. This probably should have been an open circle, otherwise then it's not a function. Note to myself to change that for next year. But it is a closed circle, so we'd have to say that x is greater than or equal to 2 there, right? So I'm just going to write in a little note for us here is that this was like an oddity, an odd, that it was like same number and they were both an equal to. That's not something we're going to see often. With finding our y-intercept, if you didn't want to use point slope form, you could have just substituted into y equals mx plus b using the ordered pairs as well, and would have gotten to the same place as we subtract minus 4/3, thinking about it with the common denominator again, 6/3 minus 4/3 would have given us 2/3. Okay, so hopefully that's a good review of our piecewise functions. So if you're looking for more piecewise functions practice, those will be the next pages in this packet. Okay. There's also options on Delta Math, as well as options on Booklet and Delta Math for the arithmetic and geometric sequences.